Something that's quite unique in linear algebra is that the ideas are really, really interconnected. Many of the ideas that we spend time on in this class become fundamentally entangled with other ideas that we spend time on. And that's kind of unique in that sense, because in calculus what we do is we build, all the ideas are entangled for sure, but there's kind of a linear progression in the way that we've written our textbooks. Right? You can go from one idea to the next idea to the next idea, and then you get to like these crescendos, right? So you get to the crescendo called the derivative in your 1A class. You get a crescendo called an integral, and all of the ideas under that were like compartmentalized, right? In linear algebra, one of the things that's really interesting is that each idea actually has like many, many different paradigms underneath, and then when we build the next ideas from that, it's not as simple to be like, oh, this idea just came from this particular concept prior to this. So a good example of that is in matrix multiplication, it's not necessarily the case that the row partition version came from the column partition version came from the entry partition version. They all are kind of existing in a space simultaneously. And then when we build the inverses, for example, we can look at inverses on any of those paradigms happening simultaneously, right? And it's not always easy to figure out what we're supposed to be doing, why we're supposed to be doing that, and how to apply that. And what that ends up meaning is that linear algebra tends to be a lot more mentally taxing in the early stages, because as students we're learning all of these new concepts, and then we're asked simultaneously to turn them around and apply them in the right situation at the right time. But the funny thing is that they're all interconnected, right? The invertible matrix theorem, and if you flip this page over, these are 24 different ways to talk about non-singularity, and they're all equivalent to each other. So these are 24 different methods of figuring out whether a matrix is non-singular. I will encourage us, in this class we're going to focus really, really heavily on the first side, and the claim that I'm going to make is we've actually already studied a lot of these without calling it as such. I want you to have this in the back pocket. I don't think I would get, I don't know, to be honest with you, if I had to choose only one tattoo from linear algebra, it would probably be the singular value decomposition. I'd probably do it like on my shoulder or something like that. This, in my earlier days when I knew less about linear algebra, I might have got this tattooed on my body, because it's kind of the fundamental result in the introductory class, that you have all of these different ways to think about this. That document is now yours. What I would like to do is talk a little bit about how to think about that document, and then I want to move on.